Here's the thing nobody wants you to admit about coding with AI. The code it hands you is going to look exactly right, clean, confident, and perfectly formatted. And a good chunk of the time, it's going to be completely wrong. That's the whole trap. AI doesn't write correct code, it writes code that looks correct. And if you can't tell the difference, you're shipping bugs faster than you've ever shipped them before. So today I want to walk you through one rule that changes everything about building with AI. Don't write a single line of AI feature code until your tests are green. By the end of this video, you'll know exactly why testing is the thing that makes AI-generated code safe. You'll have the exact setup I use to catch the wrong code before it ever reaches production. This is coming from someone who has watched plenty of smart engineers get burned because the output compiled and they trusted it. If you're getting value from this, gently tap the like button because it helps more people find it. Let's get into it now. Let me start with the hard truth because everything else hangs off of it. A large language model is a plausibility engine trained to produce the most likely looking next piece of text. When that text is code, you get something that reads like a senior engineer wrote it. The variable names make sense, the structure looks familiar, and it runs. But running is not the same as being right. Here's what senior developers see that newer developers don't. Close is not a feature. In production, close is a bug. A function that handles 9 out of 10 cases and quietly mangles the 10th isn't 90% done. It's a landmine with a countdown on it. And AI is exceptionally good at producing code that's 90% right because 90% right is exactly what plausible looks like. The last 10%, the edge cases, the weird input, the business rule that only exists in your head is invisible to the model. It doesn't know your domain, so it's guessing, and it's guessing confidently. So the only real question becomes this: how do you tell functional code from flawed code when both of them look identical on the screen? The answer is the only answer that has ever worked. You test it. Tests are the one thing that can't be fooled by code that looks right. The test doesn't care how clean the function is. It runs the function and checks whether the output matches reality. Green means it worked, red means it doesn't, and that's the entire game. Now, here's a problem most people don't see coming. AI tends to write code that's genuinely hard to test. It reaches for tightly coupled designs, functions that do 5 things at once, that call out to a database in the middle of business logic. That mix concerns together in one big blob. Tightly coupled code is exactly the kind of code that's a nightmare to write tests for. So you end up in a loop where the AI writes untestable code. Because it's untestable, you don't test it, and because you don't test it, you never catch the wrong parts. Test-driven development breaks that loop by flipping the order. When you write the test first, you're forced to design code that can actually be tested, and testable code is almost by definition loosely coupled code. You end up with small functions that have clear inputs and a single job. So test-driven design isn't just about catching bugs. It quietly forces a better architecture out of the AI. Because AI now is to make the test pass, and it can't do that with a tangled mess. So let's talk about the rule I actually enforce, because a principle without a number is just a vibe. The number is 80%. 80% code coverage enforced as a gate in your continuous integration, and it's non-negotiable. If a pull request drops coverage below 80%, it does not merge. That covers your major branches, your API contracts, and your utility functions, stuff that actually breaks in production. And I want to be clear about why it's a gate and not a suggestion. Suggestion gets ignored the moment you're moving fast. With AI, you're always moving fast because that's the whole point of using it. So the discipline can't live in your willpower because your willpower loses to a deadline every single time. The discipline has to live in the machine. The CI checks the number, the CI blocks the merge, and you don't have to be strong. You just have to set it up once. And if you're finding this useful so far, drop a comment below and tell me the worst bug an AI ever handed you that looked completely fine. I read every single comment, and the good ones turn into future videos. All right, let's get practical about what the setup actually looks like. I'll give you 2 halves of a typical stack. On the back end, let's say you're running Nest.js. You're going to use Jest as your test run, paired with the Nest.js testing utilities for wiring up your modules. The super test for hitting your endpoints and integration tests. That combination lets you test everything from a single service function all the way up to a full request response cycle. On the front end, let's say Next.js, you've got two solid paths here. You can use Jest paired with React testing library, or you can use VI test if you want something faster and more modern. Either one lets you test your components the way a user actually touches them, instead of testing implementation details that break every time you refactor. Then you wire the coverage threshold into your Jest config, setting branches, functions, lines, and statements all to 80%. You add two scripts to your package JSON, one to run the tests and one to run them with coverage. And you tell your CI to run the coverage script on every pull request. That's the gate. And once it's in place, it protects you whether you're paying attention or not. Now, real quick, before I show you the loop that ties it all together, if you're building an AI-powered business and you're a technical person trying to ship your own thing instead of waiting for permission, this is exactly the kind of thing I break down on this channel every week. Subscribe so you don't miss it. That's the whole reason this channel exists, to help experienced tech people build something of their own business before someone decides you're a line item. So here's a workflow. I call it the AI-TDD loop. It turns the AI from a liability into an actual asset. There are 5 steps. Step 1 is that you write the failing test first, not the AI, you. You write the test to specify exactly what the correct behavior looks like, what goes in, and what should come out, and what should happen when something goes wrong. This is an encoding your domain knowledge, which is the stuff the AI can't guess. Step 2 is that you hand these tests to the AI with one instruction: make these tests pass. You've just turned a vague open-ended request into a precise target. The AI isn't guessing what you want anymore because the tests are the specification. Step 3 is that you run the tests and get a green or red. There are no opinions, no vibes, and no looks good to me. The machine tells you the truth. Step 4 is the part people miss. When tests fail, you don't just sigh and rewrite it yourself. You feed the failure straight back into the AI as debugging context. The exact assertion that failed, the expected value, and the actual value. That failure is the most useful thing you can give to the model, because now it isn't guessing anymore. It knows precisely where it's wrong. Step 5 is that you merge only when coverage is above 80%. If it's under, you're not done, no matter how good it looks. The gate holds. And notice what just happened there. The AI is now doing the fast, tedious part of writing the implementation, while you own the part that actually requires judgment, which is defining what correct even means. That's the right division of labor. You're not competing with the machine, you're steering it. So the last question is where you point all this first, because you can't test everything on day one, and you shouldn't try. There's a priority order. Number 1 is your business logic and your service layer. This is where your money lives, and it's the stuff that costs you customers or real dollars if it's wrong. Test it first and test it hardest. Number 2 is your API endpoint and controllers. These are your contracts with the outside world, with your front end, with other services, and with anyone consuming your app. When these break, everything downstream breaks with them. Number 3 is your utility functions, the little helpers that get called everywhere. A bug in one of these spreads quietly across your whole code base. So a small test here serves you a big headache later. Number 4 is your edge cases and error paths. What happens on a bad input, on a timeout, on the thing you didn't expect? This is exactly the territory AI is worst at, which is exactly why it deserves a test. Work that order and your coverage climbs in the places that actually matter, instead of you wasting time testing a greater than necessary area. And before I send you off, do me one favor. If this shifted how you think about shipping AI code, hit subscribe and drop a comment with one part of your stack you're going to put a test around first. I want to see it. So let's bring this all the way back around. Testing is not the thing you bolt on after the code is done. That's the old mental model, and it was already shaky before AI. Now it's just wrong. Testing is foundation that makes the code safe to ship in the first place, especially when you've got a machine writing the code at speed. The tests are what let you go fast without going off a cliff. Set up the gate first, then build. If you do just that one thing, write the failing tests before you ask the AI for a single line, you will catch the wrong code before it ever costs you anything. That's the whole rule. That's the video. If you want to go deeper on building AI-powered solo business the right way,